Welcome to the public forum. Let me introduce Dr. Krishna Kavi, who's visiting us from the University of North Texas and Taiwan, where you're currently on sabbatical.
It's sort of a sabbatical.
Sort of one of those things, yeah. I've heard of them. He's currently the director of an NSF Industry University Cooperative Research Center for Net-centric Software and Systems and professor of Computer Science and Engineering at the University of North Texas. From 2001 through 2009, he served as chair of the Computer Science and Engineering Department there at North Texas. From 1997 to 2001, he was eminent scholar chair professor in electrical and computer engineering at the University of Alabama, Huntsville. From 1982 to 1997, he was on the faculty of computer science and engineering at the University of Texas at Arlington. He's also been a program director at the National Science Foundation for 2 years, 93 to 95. He received his PhD at Southern Methodist University and a BSEE from the Indian Institute of Science. He works in the area of computer systems architecture, cache memories, and high-performance computing. He's published over 150 articles, supervised 12 doctoral dissertations, 35 master's theses, and received over $4 million in research grants. He's currently, as we said, in Taiwan, where he collaborates with some colleagues there, also in Italy, and several major institutions in the United States. Welcome, Dr. Kavi.
Thank you very much. So I don't have to repeat all of that, right? So my background, so you already heard. And Satish Ranade and we were at the same university doing undergraduate a long time back, almost 30 years ago, I think. So, and we are rare breed because our institute does not offer undergraduate degrees anymore. So we're probably the only people who can claim that we got bachelors from other universities. They are concentrating primarily in research and graduate studies only at the university. Anyway, so you already heard my background. I always was in College of Engineering, even though we have computer science and engineering. So every place we went, computer science was always in College of Engineering. So at UT Arlington, as well as our university now. Huntsville, Alabama was in electrical and computer engineering because computer science was in College of Arts and Sciences. I just made some notes so that I will keep my time, otherwise I'll ramble too much. So. Let me talk about what I did as department chair to show my background as an administrator. I was department chair for 8 years. My new dean asked me to stay for 4 more years, and I said that's too much. I didn't want to commit for 4 more years, and that's why I stepped down. And I have the center, and NSF Center, we started last March. So I said the first year is very difficult, and I wanted to spend more time on my center, so that's why I stepped down too. Plus this opportunity to spend in Taiwan. So all of them came at the same time, so I said, I'm going to step down. So in 8 years, the department used to be in College of Arts and Sciences. They were going to start a College of Engineering, so they asked me to look into moving the computer science to College of Engineering and build, computer engineering part of it. And that's what we did in the last 8 years. And during my 8 years, we recruited about 10 faculty members. All of them being very productive, and everybody, all the junior faculty bring, on average, $250,000 a year, research funding. So I think we did a very good job in recruiting new faculty members. We had 3 career awardees during that time, 1 PCASE awardee. And to give you some numbers, in the last 8 years, our departmental funding went from $200,000 entire department to $2 million per year now, expenditures. Our PhD enrollments went up from 19 when I started to 55 now. We have 55 PhD students in the department. And publications went from 30 entire department 100 publications. So research productivity improved significantly. Our enrollments have gone up too, both at graduate level and undergraduate level. If you follow the national trends, you probably heard that computer science had dipped, right? But we never dipped, because we came up with very innovative programs, outreach programs. We started a summer camp, engineering summer camp, just for girls, high school girls. And that got so much recognition that we were on CNN, our department. So we did certain things to maintain our recruitment and activities and so on. Our programming teams every year won national championships, or they have, this year I think they're going to Beijing for ASEAN, so the finalists. So I think we did lots of outreach activities that got a lot of recognition for us. Our minority and women enrollments in our department reached as high as 30% at one time. Now we're back to like 26 or 25%, so, which I think is pretty significant for us. And other achievements I take credit for is accreditation. Our computer science department never received a full accreditation until I joined there. In 30-year history, we got a full accreditation in computer science in 2003. We started a new computer engineering program. For a brand new program, we got 6-year accreditation. That's less than 1% in the entire nation. So I think we have very strong academic programs as well as research. And I was telling somebody a few minutes ago that we started a new undergraduate program in IT. It's called BS in IT. What's unique about that is we require all students to do a 18 hours minor outside of engineering. And they have to do a capstone project applying IT solutions to the minor. So we have some pre-med students. So it's like pre-med engineering. We have pre-law engineering. We have business students, political science, all of them. So we don't expect them to be engineers, but they get very strong understanding of IT. So when they become doctors, they know what IT means. When they become politicians, they know what IT means, if they're going to write policies. Or they can be lawyers and they can be in patent law, for example. They have a very solid background in engineering. And that started last year. We already have 200 students in that program. So we did a lot of innovative programs and outreach activities and so on. Our summer camps now are very stable. So we used to do the summer camp only for girls. So most of the parents said, "What about my son? Why aren't you admitting my son?" So we expanded that. Now we have both for boys and girls now camps, and it's funded at the level partly from state, partly from NSF. ExxonMobil funds us. Motorola Foundation funds us for the summer camps. So on average, we get about $200,000 to $300,000 for the summer camps. So given this experience, I think maybe I want to try my hand at the next level as the dean and see what I can do. So that's the reason why I'm interested in exploring the possibility of becoming a dean. And I think, as I said, after 1 year, my center will be stable. So the first year is difficult because we need to make sure that our industrial members will stay with us. It's an industry university collaborative center. We have 20 companies now and 4 universities. 3 universities in Arizona is going to join us soon, Arizona State. So it'll be 20 companies with the 4 universities. Each company puts $30,000 per year membership. And NSF funds us about half of that, so we get about $300,000 from NSF. So it's about $1 million now. So the first year is difficult because if you don't deliver, the companies are going to leave. So I wanted to make sure that I don't take on anything for the first year to build. And we're finishing our first year by the end of March. And we haven't lost any other companies so far. And we are trying to add new members. Intel is likely to join us. I've been negotiating with them. I thought AMD is going to join us too, but they just dropped out recently. Their budget didn't approve this year. So. But I'm exploring that. NASA is going to join us. Not only industries, but government agencies also can become members. They pay $30,000. So. So anyway, so that's one of the reasons why I thought, maybe I have some ideas I want to explore becoming a dean. And also being dean is usually the next progression after the department chair, right? So I thought I'll try that. I always tell people saying that you can always learn from a bad administrator. So I think I learned a lot from some of our bad deans we had. They're not bad in the sense that they're, as a person they're bad, but they made some really bad decisions. Our previous dean, College of Engineering, as I said, we started a brand new college, right? He comes and starts willy-nilly 4 new departments without any resources. And they started with programs, only undergraduate programs. They're going to add PhD later. Now they can't get faculty. Nobody wants to come there without a PhD program. So I think that's a very bad decision. I told him that, at that time, and I fought with him several times, but he said, no, we have to start these departments, So I think, that's what I mean by some bad decisions made by some people like that. I've seen some deans who just wanted to maintain status quo. And I think, again, that's really not good. I will not go someplace where they're going to ask me to be just manager and maintain status quo. So I have my challenges, wherever I am, I'll be glad to stay and take those challenges, so. And I've seen some deans just promote themselves, they were there for 2 years, they already started looking for provost jobs, So I've seen some deans. I don't want to be like that. So I learned a lot from those kinds of decisions made by them. And I learned likewise from bad chairs also. So I think I learned from that and used some of those learning, and I became department chair. And I'm sure if you talk to some of our faculty, they'll probably say that I did some bad decisions too. But as I said, we are proud of the achievements we have in our department. So next question might be like, why New Mexico State, right? I know New Mexico State is very strong in engineering, being an Aggie school, so that's why I'm very much interested in looking at New Mexico State. And I have some understanding of what you have in terms of programs, your research centers, and there are lots of opportunities, right? We have all these Los Alamos and Sandia, White Sand missiles. So there are opportunities. So that's what I want to explore. I also know there are challenges. The budget is a big, issue right now, right? So I know. So I want to explore what's available, whether I would think that those are right challenges for me or not. After talking to you, talking to administrators and so on. So I want to explore the possibilities. And you might ask me what's my vision. So I was quoting one of my mentors who used to be dean at E.T. Arlington, one of the better deans. He used to say that if anybody asks what my vision is, he used to say that I'm not going to be presumptuous, so that I go to a new place and say, hey, I have this great vision, which indicates that you guys have no vision at all, right? So I would be in the same mode. Say, I'm not going to say that I have new vision. I looked at what your strategic plans or visions, whatever is available on the web, and many of them are what I would have said would have been my vision too. So there are some things I like, what you have. So if I were to come here, I'm not going to come up with new vision. What we want to do is look at your vision, what you have documents, and take few of those, focus on them. So let's not try to achieve everything you said, but let's focus on a few of them, try to achieve them. So for example, some of the visions I read about you, university is, New Mexico Engineering wants to be a leader in innovative research and education, meet the needs of New Mexico industries, leader in extension programs, promote diversity, achieve top 25 ranking. Those are all good, statements, but what does it take to achieve them? What kind of resources do we need to achieve them? So that's where I think my focus would be. And also look at what can be achieved in the near term. To achieve top 25 ranking in engineering, you need to have at least, say, 200 faculty members in College of Engineering. I don't think there's any top 25 engineering with less than 200 faculty members. You think you will ever get 200 faculty members in the engineering? So maybe what you want to do is what can be achieved with the available resources. So that's what I would be looking at if I were to come here. Of course, some of the other goals you have, you don't need new resources. What you need is commitment from faculty involvement, and outreach activities and so on. For example, some of our faculty members didn't want to do research but wanted to do the outreach activities. And I let them do it and I rewarded them. And as I said, our summer camp for girls got notice from CNN, what else we need in terms of getting recognition than that. So I rewarded people, So some of these activities, some of the outreach activities, if there are faculty members who want to take pride in doing those kinds of things, I think we should allow them to do it. As long as they're good at it, do those things. So there are certain things that can be achieved without new resources, but involvement of the faculty and staff. And some you definitely need resources. If you need top 25 ranking, you need more faculty. So that's why you need to look at what's achievable in the near term. And so on. So that's my vision statement, if you want. But there are a few things that we tried, and some of those things we can explore here too. There's a lot more emphasis nowadays on industry, university involvement in engineering. And I think we want to look at that, more industries involved, in addition to what you already have. Expand beyond New Mexico. You can have aerospace industries, which are not just Boeing, but I'm saying that you can bring Lockheed Martin in involvement, or some other aerospace industry, or electronics. You have a good engineering program here. Let's bring some industries like TI or somebody to work with us on some research. And my center has TI as a member, so I have some connections with the TI. As I said, we're trying to get Intel involved in our center. So we want to expand industry involvement beyond what you are currently looking at. And there's a lot of funding too, NSF. IUCRC is one of the smaller centers. They're easy to get. They're not that difficult as long as you have industrial memberships. But there are also other programs like GOLI. I don't know how many of you have heard of GOLI program, or PFI, Partnership for Innovation. So there are lots of programs with industry-university collaborations, not just at NSF, but other agencies also. Build innovative interdisciplinary programs, both research and education-wise. As I said, our BAIT program is multidisciplinary because it requires students to take a minor outside of that. So maybe we want to think of exploring interdisciplinary type of programs. There was an article recently, I think, Chronicle of Higher Education, that talked about the 5 fastest growing majors. I'll list them here, but they have service science. Usually when you think of service science, you think of hospitality, management, or hospital, hotel management, those kinds of things. But they're talking about now bringing industrial engineering and management for emergency room planning. That's a service, right? Our healthcare workflow in doctor's office and so on. So they are bringing engineering and science to those areas, and they said those are very fast-growing programs. And I know you have the electrical utilities management program. That's a service. You can say, look at that as a service provider. So the other majors, fastest-growing majors, are health informatics, sustainability, computational sciences, and public health. And I think the College of Engineering here can participate in many of those. And also, the reason why I started the BSIT in our university is National Academy of Engineers had some documents like Engineering 2020, Engineering 2025, and so on. One other thing they said was all the policies are going to be written by non-engineering people, but we need to try educate those people who are going to make policies in engineering. So they call it engineering for liberal arts people. That's what they call it. So our BAIT is, in a sense, is engineering for liberal arts. As I said, it's a very fast growing program. In 2 years, we went from 0 to 200 students. And you have, I think, 5-year accelerated programs. I don't know how popular they are, but I think they're going to become very popular soon. Because bachelor's is no longer the first degree to get jobs in this country. So I think the 5-year accelerated programs are going to be popular. You may want to push those. And there is funding from federal agencies, particularly for scholarships. If you identify good people, students, you can fund them through these scholarships during the last 3 years. So pick them at the junior year and ask them to continue into a 5-year program, fund them last 3 years. I know DOD has a lot of funding for those kinds of programs. And the other one strategy we tried was build partnerships, both within the university, across multiple universities. So, for example, I always work with the faculty from other universities. I had grants jointly with Penn State, Washington University, UC Irvine, So I had, and I encourage my faculty too. One of our very productive faculty member, he brings almost close to $600,000-$700,000 funding, but most of them are jointly with Columbia University, Purdue University, Texas A&M University. So that's the only way you can build teams so that you can go after big grants. So that's, I think, something that I would encourage if I were to come here. Interdisciplinary, like biomedical, or materials, environmental sciences, and also seek funding for multidisciplinary programs like IGERT. So IGERT is very difficult, very tough competition, but if you get IGERT grant program funded by NSF, I think it funds almost like 20 PhDs per year or something like that. It has to be interdisciplinary, and it will be very prestigious too, so you get a lot of recognition if you get IGERT. Likewise, the DoD has MURI programs, multi-university research instrumentation, and infrastructure. So those are the kinds of things you can try to build, and we have been successful at the UNT doing that. I think that it can be done in other places too. So what I need to do if I were to come here is understand the political climate and the culture of the faculty here to see which strategies work and what kind of input I can get from faculty and everybody so that we can build and again, focus on some key goals that can be achieved. We don't want to hit the wall when we know it's not going to be achieved. So, we want to make sure that there are certain goals that can be achieved and focus on it. If anybody's interested in any one of those in more detail, I'll be glad to explain those. But I thought I'll give you a quick overview and open for questions because I don't want to take all my time just talking. So. Yes.
It's one of the things we have coming up here over the next year or 2 years is our ABET accreditation. What's your comfort level or understanding of ABET, I guess?
I was an ABET program evaluator for computer engineering for 6 years. And as I said, for the first time in the history of our department, we were able to get ABET full accreditation for computer science. And a brand new computer engineering program we started when we went first time for accreditation, we got 6 years. So I know a lot about ABET. I know how to make ABET accreditation very successful. So I know a lot about this. As I said, everybody was surprised that brand new for computer engineering we're going to get 6 years. Even I didn't expect 6 years. So yes.
From an outsider looking in, what challenges do you see that we face as a college here?
There are several. Most of them are related resources. Faculty, for example. I was really amazed looking at your published information. The College of Engineering has only 58 tenure-track faculty members. Is that right? Officially, that's what they published. That's very small. You need to look at close to 100. UT Arlington has 100 faculty members. and it has 6 programs, I think. They don't have engineering technology, but they have 6 programs, I believe. I forgot, 6. But they have something like 114 faculty members. Even our college, which have basically 2 major programs, computer science engineering, material science, those are the only 2 with PhD programs. We're electrical without a PhD. As I said, our new dean started this. And now there's so much difficulty keeping the faculty or getting good students. We started mechanical, same problem, you know. But anyway, and we have engineering technology also. With only those programs, we have 70 faculty members. So that's one challenge we'll be looking at. The other thing is, I also know that your salaries are below national average. Our salaries are not. If I tell you how much some of our junior faculty, assistant professors make, you probably will be surprised. One of our assistant professors who got the TK's award, her salary is like $110,000. So you need that kind of thing to attract high quality people. You know, I would not say she didn't deserve it. I think she deserved it in salary, but we were able to do it, and that's why we get good faculty, very high caliber faculty. And of course, another problem most of us have is good students. How do we get good students? So what can we do to get good students? One of the things we are doing at UNT is making our stipends, both research assistantships and teaching assistantships, to the national level. So we are mandating, if you're writing a grant, you have to put at least this much for a research assistant. We're looking at something like, I think, 18,000 minimum plus 7,000 for tuition. So you have to put $25,000 per student. So those are some of the challenges that I'll talk to the president tomorrow.
Well, the number of faculty that you mentioned, it's strange that this place has a bean counter approach to that, and they strictly go by the student credit hours.
Same thing our university do.
So must have increased the student credit hours substantially?
So what I did was I took that as chairman. I said, give me this many faculty, we'll produce this much. So it's not saying that after the fact, saying that we have this many students, give us the position. But I asked them to invest, which they did. And that's why we have, in our department, I think 22 tenure track faculty positions, and we have 5 lecturers. So we can offload some of the teaching to them. Lecturers teach 4 classes per semester. But we have 600 undergraduate students and 200 graduate students. So. But when I came as a department chair, I asked for 6 new positions. I said, if I'm going to build computer engineering, I need that money. They gave. But in return, I said, this is a challenge I will take. If I don't achieve in these 5 years, fire me. I'm not afraid of taking challenge, but they have to put the resources.
I'd like to ask a question about research productivity. My name's Bobby Derlin, and I'm from a different college, and I'm not an engineer, just so you know. You cited some statistics with a rather dramatic increase in publications, and I have sort of 2 questions buried in this issue. One, how did you motivate faculty to achieve those levels? I'm assuming that all of your faculty embraced the pressure to publish with equal fervor. And how did you assure that you weren't just getting more rather than more and as good or better in terms of the quality of the publications?
Let me start with the last one first.
Okay.
Quality is very difficult to judge. This is always I get in fights. We have one faculty member that writes one paper, and is more theoretical faculty member, and he claims that his one paper has 10 theorems, so it must be good. Right? So I said, you cannot make judgments based on that. So you have to have peer review. right? So the quality of a publication is based on how many citations other people have onto this, how much recognition this paper has produced, which may take 3-4 years to see that. But if you have a pipeline, then you can see the quality of the person's productivity. And grants, you know, if you don't have the publication, you're not going to get money for this, or you're not going to get awards and those kinds of things. So those are all ways of measuring quality. You can't generally simply say that somebody's published 10 papers, so they must not be as good quality as compared to one person publishing on one paper is somehow good quality. So, you know, it's very difficult to judge what's the quality, you know. So that's why I base my judgment about quality on what others are saying. So, how did I motivate? What we did was in our department, we developed a workload policy, and we came up with guidelines on how to reward faculty for productivity, and now that's been adopted by the entire university. So, as you probably know, most universities have 2-on-2, right, for faculty members teaching, you know, 2 courses per semester if you're doing some research. So we came up with a formula saying that each class counts for 10% of your workload. So if you're teaching 4 classes per year, that means your teaching workload is 40%. And everybody's counts service 20%, so that's pretty standard rule, right? That means your 40% of your time, your workload should be research. And we came up with a way of evaluating what's the minimum requirement to have 40% research. If you're not doing 40% research, then maybe your teaching has to go up. If you're doing more than 40% research, based on the measures, you will have reduced teaching. So we are able to balance that. And I was telling you earlier that those evaluations are not done by the department chair. It's done by faculty. So we have a faculty committee. So that's why the faculty can trust. It's not based on what chair thinks, you know. It's based on what the faculty committee thinks. So that's how we're able to, you know, motivate people or, you know, balance. I'm not saying that everybody has to be a researcher. But if they're not doing research, they have to compensate somehow for their 100% workload. So, and I think we use the formulas 10% because it's easy that way to count. If you want to buy out a course, pay 10% of your salary. So it's easy to do it. As I said, that worked out very well. The entire university adopted the policy. I know you have a workload document, by the way, I saw it, so. You're not unionized, are you? Faculty here?
Let's talk of it. There's a movement to unionize. What do you think of that?
I don't know. I think I don't like the unionized model. The reason for that is you cannot reward productive faculty members because the flexibility is gone, you know, by unionizing, because everything's bargained through union. Incidentally, I was offered a deanship at a university. When I found out they're unionized, I said no. So.
Where do you see the role of distance education and engineering education, or what New Mexico State's role could be in that?
I think that was asked this question at the phone interview. There are certain things in engineering we cannot do distance. For example, labs and so on. So there's a limit to how much you can have distance education in engineering, unless we can somehow facilitate even lab experiments and everything at distance. I'm not really sure that they will get the same kind of education, engineering education. So I think distance education is much more limited in engineering than other disciplines. But you can offer, you know, executive master's programs, those kinds of things in distance education, or like engineering management, those kinds of things. So I have to look at it in exactly what can be done. You can offer distance learning in education, in engineering, if the remote locations can accommodate the lab experiments and so on.
I'm wondering if you could share a little bit about some of your perspectives on when services and I'm thinking of services that support the academic enterprise should be centralized versus decentralized to the level of the college. And I'll give you 2 for instances that relate to some of the topics that have been raised. The development of the workload policy that the university has now here at New Mexico State was hindered, I think, by the perception that its initial drafts were too highly controlled by our central administration. And I think faculty, there was pushback because of that. Centralization of some of the support functions for faculty research versus having services available closer to faculty in the college is sometimes perceived as limiting a faculty member's ability to be creative and innovative in their research, respond in a timely way. So how do you kind of figure that out from your perspective as a
I've seen both sides of those kinds of models. For example, the workload worked very well for us because it's developed in our department by our faculty within the general guidelines, within the university parameters. So even now, when university adopted our guidelines, they don't dictate the same level like what does 40% research means. It means something different in engineering compared to some other place. So the university allows each unit to make those kinds of judgments, what's 40% means, what 20% means, and so on. But they came up with this general rule saying that teaching one class means 10%. But you had to account for 100%. So there are general parameters that you can agree on. So that was not a problem. In terms of other services, you have to look at the efficiency. So if somebody can convince me that by moving all these operations to central location, we're achieving efficiencies that are not possible without that, then maybe there's a value to this. But particularly for research, our research services are centralized. However, we also have additional staff within the college to help faculty with some of these things. We used to have within the department, because we were growing so rapidly, we wanted some help managing budgets and everything for faculty within the department. But our new dean came and said, that's very efficient, you're not using resources efficiently, so you moved all of this to college. Anyway, I don't know if it's going to work well or not, we have to wait and see. But, because, faculty can go to the budget person, I said, I want you to prove this, so you can do it in 5 minutes. Now you have to go to college level, so it might take a day. And if you centralize, at the university level, it might take a week. So you're paying that cost, but if somebody can convince that you're achieving efficiencies to offset that somehow, then we'll look into it. So we have to look at each particular thing, whether it's good to move into centralized or not. For example, University of North Texas, I don't know if you know Texas. Texas is very strange in terms of academics. They're probably strange in every aspect. There's not a single system. University of Texas has their own system with like 14 campuses. UT Austin is the largest. Texas A&M has like 6 or 7 campuses. University of Houston has 3 or 4 campuses. Those are all different systems. University of North Texas is also a system. We have 3 campuses. We have medical school, our main campus, which is Denton, where I am, and we started a new campus in Dallas, North Texas, Dallas. So we have 3 campuses. We're going to start a 4th law school soon. So there are 4 campuses. The chancellor said that he wanted to centralize all the computing, maintaining, networking, and all of those operations because he claimed that that improves efficiency. Our president fought in saying that our campus is the largest campus with 36,000 students. We need our own people. And chancellor basically said, hey, fine, do it, but you're not going to get extra money. So he's trying to, convince, saying that somehow you're gaining efficiencies because of this. So our president is coming up with ways of saying that, let them do whatever they want, I'm going to do this. So you may have to do the same thing. You might say that university is pushing for this, maybe college can come up with some other ideas to fund these operations because we feel this is more efficient for us.
I have one last question. And it has to do with how you figure out what to do when you don't have money. Right now our legislature is in session and, you know, things are grim economically all around, and I mean, I'm not telling you anything you don't know. But the prognosis so far is that no matter how many arguments and good positions we win in Santa Fe, that our institution will be placed in the position where there will need to be some cuts. So how would you, in that environment, decide what to cut?
You can come up with some ways of handling that. Texas did this about 6-7 years ago. Texas is doing pretty good now, but 6-7 years ago we had budget cuts. So what they did, this is legislative wise, and I don't know if they can be done here, is they decentralized the tuition control. So it said each university can set their own tuition. So maybe that's possible. And that gave us a lot more flexibility, because now if we are good university, we can charge each student $1 more, and we're not going to lose enrollments because of our reputation. And that was good. That's how they control UT Austin. If they did not have that tuition control, UT Austin enrollments would have reached 60,000. So because they are so much in demand, they were charging more, and that's why they were able to control. So it has a lot of benefits of doing that. And our university even allowed College of Engineering to charge higher, because College of Engineering education is more expensive. Faculty are a little bit more expensive, labs are more expensive, and so on. So we have differential tuition. So those are some of the things. I don't know if they allow here. Maybe you have to fight with the regions to allow you to do that. So so that you can raise other ways of making money.
Thank you.
And there are a few other ways of doing it. One other thing we tried to explore when the previous president was there, there's something called responsibility centered management, RCM. University of Michigan does, and a few other universities do. By that, what it means is each unit has to generate their own money with the students, tuition, research funding, or any other way. So basically, everything you generate, the central administration takes about like 30% in overhead, but the rest of it comes back to the units. So you have a lot more control and a lot more responsibility to do this. But that encourages a lot of innovation too within each unit. And some of the colleges can offer certificate programs, offer training programs. All the money stays within the college. So you can encourage people to be very entrepreneurial about it, and so on. So I was telling earlier that College of Music, our College of Music is very highly ranked. They're in top 10 College of Music. Jazz program is #1. They were afraid that the responsibility centered management would be bad for them because they don't generate as much tuition. And I was on the committee looking at this. I said, but they can be very innovative in their own way. If they're that good in music program, they can give concerts, they can give performance and raise money. So, again, when we had new president, she killed this program so bad. I said, so there are ways of encouraging people to be very entrepreneurial when budgets are tight.
Thanks for coming, everyone. And get Dr. Kavi to his next appointment shortly.
Thank you very much.
Thank you.